We're continuing with our problem to see whether or not cell phone use impairs driver reaction times in a driving task. So we've done a lot of analysis. At the next point, they want to know the test statistic and the p-value. And so I want you to notice that they've been highlighted right here for you in the computer output. The test statistic is your t-stat, it's t0, and your p-value is in green, right? So the p-value is, there's a little bit of a discrepancy between the two. Statcrunch just says it's less than, that's a less than symbol, 0.0001. Minitab says it's 0.000. So let me go put those right here in these two places right here. Oop. All right, so there are those values right there. Now I wrote up both of the p-values because they're both okay to look at, and you can write either one depending on which Minitab or Statcrunch you were given. Now the question is the value really 0.000 like Minitab claims? And the answer is no, not really. The thing about Minitab is that it basically gives up. It kind of says, oh, that's good enough, and walks away from it. But we have to know that Statcrunch is actually the better way to write it. What it's saying is that it's really, really small. There's more than 3 zeros in this problem. So it could be 0.0000002 or something like that. So just know that it's a very, very, very small value. It's less than 0.001. Matter of fact, just to clear that up, I'll just say p-value is less than 0.0001, so it is very, very small. All right, now they want us to use the computer output to perform step 4. So that's that drawing the graph and labeling it and shading it appropriately and everything. And this is actually easier than you might think because all you have to do is look at the computer output or the inferential statistics output. So let's go down here. You're doing a paired t-test, so that's this one right here. And you want to do the p-value method, and it's a left-tail test. So you're drawing that middle one right there. And keep in mind, you want a very, very, very small tail because, well, their p-value is extremely small. So small that Minitab basically calls it 0, even though it's not 0. So I've drawn that with a computer. And you can see, in order to fit this in, I really had to go out there. Negative 5.46 standard deviations from the mean, that was your test statistic. That is extremely small. And so it's very, very, very tiny over there. And the p-value that goes with it would also be extremely small. All right, now, what will we get to do? Do we get to reject the null hypothesis? That's what that means. Statistically significant, if you'll remember from chapter 10, means do we get to reject the null hypothesis? You're basically a constant teenager. You want to rebel against the null at all times. So the answer to that is for sure yes, right? You are able to reject your null hypothesis if your p-value is less than alpha. P-value is constantly the same thing. You always reject if your p-value is low. So our p-value is definitely less than alpha. Alpha is 0.05. Therefore, we would reject the null hypothesis. And that's what statistical significance means, right? Statistical significant means that you get to reject the null, right? It's not significant to let the null stand. The null is what you assume to be true in the first place. It's only interesting to you if you're able to reject it. All right, now what conclusion would we reach? Well, we were able to reject the null hypothesis, and that means that there is enough evidence to support the claim that using the cell phones impairs reaction times of drivers. So that using cell phones impairs reaction times of drivers, which should not be a shock to anybody. So if you use your cell phone, it takes you longer to react to things, like a deer running in front of you or somebody swerving into your lane, that kind of thing. So in other words, the sample data supports that driving reaction times are longer, which is not a good thing when using cell phones. I don't know why I capitalized cell phones there. So remember, as a driver, you want to be able to react to things quickly, right? You're driving a large piece of machinery, you want to be able to swerve if you need to swerve, things like that. So using a cell phone makes it so it takes you longer to get things done, and that's not a good thing. And then let's remind ourselves, if the decision we made above is incorrect, what type of error would you be making? Let me grab the chapter 10 notes real quick. There, this is in chapter 10, 10.1 as a matter of fact. So take a moment, you can pause me and go find it. And it's saying, look, there are two major errors you can make. You could reject the null hypothesis when H0 was true and the alternative was false. Or you could not reject the null hypothesis when H0 was false and H1 is true, and that would be a type 2 error. Don't worry so much about false positive, false negative. False positive and false negative, those terms are used more for medical testing, drug testing, like pregnancy tests, things like that. All right, so we rejected the null hypothesis. We said driving with your cell phone, using your cell phone impairs your reaction time. So we were saying we rejected H null. So if you were going to make a mistake, it would be a type 1 error, right? Because our decision above was to reject the null hypothesis. So let me write that. So let's see if we can say this. So type 1 errors reject H0 except if H0 was true, except it was true and H1 was false. So if our decision is above is correct, that would be a type 1 error because we rejected H0. Oops, the null hypothesis above due to our small p-value. So since we rejected H0, that means it must be a type 1 error if we were making it incorrect. Now again, there's no guarantee we are making an incorrect decision here, but if it was incorrect, it would be a type 1 error. All right, well, done with that problem. I'll stop right here and I'll pick back up with the next problem, which I believe will use a confidence interval.